Welcome to lesson 2.7. This lesson really is a lot on defining different vocab words that we will use throughout the year, really, but definitely when we're talking about functions. So some of these you have definitely seen before, so it should be a review. You know what the y-intercepts are. The y-intercepts, there could be one, there could be more than one, but they are where the graph or function crosses the y-axis or intercepts it. Okay? So y-intercept. Now, if it is a y-intercept, the x will always be 0. Always, right? The y-intercept, the x coordinate of the y-intercept is always 0. The x-intercepts, also known as the zeros or the solutions or the roots, that's simply where the function crosses the x-axis. And similarly to the y-intercepts, with the x-intercepts, the y will always be 0, always. So the y-coordinate of the x-intercepts will always be 0. Okay, so to tell if a function is increasing or decreasing, we always read left to right, okay? And if it's increasing, it will be going up, left to right. And if it's decreasing, it will be going down, left to right. Okay. When we talk about a positive or a negative function, okay, we're talking about will our outputs be positive or will they be negative? And remember, the outputs are the y's. So a positive function it will be positive. It could be both. It could be positive or negative, but it will be positive if it is above the x-axis or where it is above the x-axis. Because above the x-axis, all of those y's, the y values, are positive. If they ask for when is the function negative, you're going to look for when is it below the x-axis. That's where all the y's are negative. A maximum is, I think it's pretty self-explanatory, it's the highest value. The minimum is the lowest value. And we actually have already gone over domain and range. But really quickly, the domain are all of the x's, the x values that exist for that particular function. Sometimes it's not, a lot of times, I should say, sorry, the domain is from negative infinity to infinity because you can plug in any x. But there are functions where you can't plug in every x. Specifically, what we have worked with in the past are fractions. You can't have 0 on the bottom. Square root functions, there can't be negatives underneath the square roots. So those are the two we've worked with most recently. So not every x, x value will be able to be plugged in for a particular function. So just be careful. But a lot of times, the domain will be from negative infinity to infinity. So the x values that exist for that function. And then the range is the same thing except for it's the y's. So that is the y values that exist. And that will be different for every function. Sometimes, again, it's negative infinity to infinity. You will get every output you could imagine. But more often than not, the range is not negative infinity to infinity, whereas the domain probably will be. So let's consider the function g of x. So they chose g this time instead of f of x. G of x is the function 2 times the absolute value of x minus 1 minus 8. And they only want you to graph it over the following domain. So you don't have to plug in, every number that you can fit on this graph. You only have to go from -4 to 7. So I'm going to start by showing my work for the first one, but then there isn't very much room. Maybe I'll do a couple, but then I'm going to just do them in my head. So first I'm going to plug in -4. So if you plug in -4, that's going to look like this. It's going to be 2 times the absolute value of -4 minus 1 minus 8. So I'm not going to have enough room to show all of my work for all of these, but I'll just show detailed steps for the first one. So -4 minus 1 is -5. Well, the absolute value of -5 is 5. So you're going to do 2 times 5 minus 8. Well, 2 times 5 is 10. 10 minus 8 is 2. So that means g of -4 turns out to be 2. So I'm going to plot that point. My input is -4, and 1, 2, 3, 4. The output turned out to be 2. Now you would plug in -3. So if you plug in -3 for x, I'm going to kind of talk through this one. -3 minus 1 is -4. The absolute value of -4 is 4. 4 times 2 is 8. 8 minus 8 is 0. So the output for -3 is 0. Now we're going to plug in -2. -2 minus 1 is -3. The absolute value of -3 is 3. 3 times 2 is 6. Minus 8 is -2. So -2, -2. Now we're going to do -1. -1 minus 1 is -2. Absolute value of -2 is 2. 2 times 2 is 4. Minus 8 is -4. So -1, -1, 2, 3, 4. You'll notice we're going down 2 each time. There will eventually be like a pivot point where you're going to turn and go up. So you just got to be careful that you know when that is. So I wouldn't just keep going down 2 unless you know where that point is going to be, the turning point. So 0. 0 minus 1 is -1. The absolute value of -1 is 1. 2 times 1 is 2. Minus 8 is -6. So 1, 2, 3, 4, 5, 6. 1. 1 minus 1 is 0. The absolute value of 0 is 0. 0 times 2 is 0. Minus 8 is -8. So that's down here, 1, -8. Now after I do the next one, you're going to notice something, and then you'll know how to kind of do a little shortcut to get the rest of the graph. So let's plug in 2. 2 minus 1 is 1. The absolute value of 1 is 1. 1 times 2 is 2. Minus 8 is -6. So you'll notice we're starting to go back up. So now for the rest of it, since I only have to go to 7, it's going to go up to over 1 until, and I only have to do up to 7. So that's 1, 2, 3, 4, 5, 6, 7. So that's almost the last line. So up to over 1, up to over 1, up to over 1. And then we connect. Do not put arrows on the ends of your graph because they only wanted the specific domain. They did not want you to graph this entire function. They just wanted that domain, so you're only going to graph those points. So do not put arrows. Okay, now we're going to answer some questions based off of this graph. It says state the domain over the domain interval over which this function is decreasing. So remember, we read left, whenever we read a graph, left to right. And whenever you read in English in general, you read left to right. So where am I going down? I'm going down from the start, which we started at -4, all the way until we got to 1 on the x-axis. And it says domain interval, so that's why I'm looking at the x's. So I went down from -4 to 1. And if you recall, back in algebra, you learned that if you use these kind of brackets, it's like using the equals to, right? And if you use open parentheses or curved parentheses, that's like doing less than or greater than, no equals to. So because it does include -4, I'm going to use a square bracket. And technically at 1, it's not decreasing anymore. It kind of is at a standstill, so it doesn't include 1. That's where it's turning around and starting to go up. So now it says state the zeros of the function on this interval. The zeros are where the graph crosses the x-axis. So the zeros are at 1, 2, -3, and 1, 2, 3, 4, +5. So the zeros are at x equals -3 and x equals 5. All right, the next question says state the interval over which g of x, which is our function, our graph, is less than or equal to 0. So it can be equal to 0. And it also has to be less than 0. So what that means is where will your outputs be negative? Where are they going to be smaller than or equal to 0? So my outputs are negative or equal to 0 from the x-axis down. So the interval in which that happens is from this point right here, which was -3, all the way till this point right here, 5. If you look at all of those x values, they produce outputs that are down here below the x-axis. So the interval on which my function is negative or less than or equal to 0 is from -3, and it includes -3 because it said it could be equal to 0, all the way to +5, and it includes +5 as well. All right, the next question says evaluate g of 0 by using the algebraic definition of the function. What that means is plug in 0 into the function. So they want to see that work. So we're evaluating g of 0. So that is 2 times 0 minus 1 minus 8. So 0 minus 1 is -1. The absolute value of -1 is 1. 2 times 1 is 2. Minus 8 is -6. Now it says, what point does this correspond to on the graph? Well, if you look down at -6, it's right here on the y-axis. That happens to be the y-intercept. And that should make sense because we plugged in 0 for x. And if you notice over here, we said that the y-intercepts will always have an x value of 0. Okay, the last one says, are there any relative maximums or minimums on the graph? If so, which and what are their coordinates? So there is a relative maximum or minimum. Oh my gosh, I'm so sorry. There's a relative minimum right here. That is the lowest point on our graph. It is where the graph turns around from going down to then up. So that point right there has a coordinate of 1, -8. And that is our minimum. So let's label that as a minimum. Okay, and that is it for this lesson, 2.7. It just really talked about different vocab words and then how to identify them on a graph. Just be careful that you graph the proper domain. If it is specified, sometimes it doesn't specify, so that is when we would graph as many points as we can and then put arrows on the ends of our graphs to signify that it goes on forever. But if they tell you a specific domain, you graph specifically what they asked. Do not go any further. Okay? And today, or next class, we will spend time practicing this and reviewing for your test, which your test will be the following class. So start studying now and get in for help if you need to. Good luck.